Hi again. So let's move on to talk about the lipids. So what are lipids? They are fats and fat-like substances. Doesn't that look good? Well, actually, I think we can do better than that. Now, this I like better. Oils, avocado, fish fats, nuts. Really, for our culinary explorers, I would say that think of the Mediterranean cuisine. To this picture, we could also add cheeses, ice cream, and so on. So, when I think of lipids, I always think of Paula Deen. I miss the good old Paula Deen, back when she was more fun and not all this healthy stuff. But really, to be serious, we all need some amount of fats. For example, fat-dissolved vitamin requires some to be kept in the body. But the fact of the matter is that a typical Westerner consumes these days too much fats. And I do think that it is partially because we are evolutionary hardwired to love fats. As back in the day, that was vital for our survival when reliable sources of nutrient and energy-rich food were sparse within the earliest humans. Fats serve many purposes in animals. They are a great form of energy storage. Remember, we talked about how hard it is to get rid of fat when dieting. In addition, many animals, such as polar bears, rely on building a thick layer of fat for insulation for the winter. In addition, fat cushions. We have internal fat to protect some of our vital organs. In fact, you would find out that if your body fat percentage is very low and you get into an impact accident, you could have more serious injuries. In addition, oil helps to waterproof the skin, just as an example. And I always tell our kids, if they get bullied, fat kids are harder to kidnap. For clarity, that last one is just a joke. So let's look at the structure of a typical lipid, may it be fat or oil. They contain two types of subunits, glycerol and fatty acids. A glycerol contains 3 hydroxyl groups. Remember, they are those OH groups that we saw in our listing of common functional groups. These hydroxyl groups are polar, and therefore glycerol is soluble in water. When we later look at a structure of a phospholipid, you will notice that the part where the glycerol is, known as the head of a phospholipid, likes water. In addition, we have something known as a fatty acid. This is a long chain of carbon atoms, bonded only to one hydrogen with a carboxyl group at the end. But to be completely precise, when a fat or oil forms, 3 of these fatty acids join with the hydroxyl groups of a single glycerol. If you remember our earlier discussion of dehydration synthesis and hydrolysis, this would be now a dehydration synthesis reaction, because in addition to the fat molecule that is formed by combining these 4 units together, 3 water molecules result. But not all fats are alike. You might have heard about good fats and bad fats. Let's dig a little deeper into this. So the fatty acids, these long carbon atom chains that we just talked about, can differ. And these little differences between them have huge consequences. Let's look at that. So unsaturated fatty acids have a double bond in the carbon chain, which causes the number of hydrogen atoms attached to differ. And the shape of the chain to be disordered if you wish. These are typically oils, which are in general liquid in a room temperature and are considered as a better option for your health. Saturated fatty acids, however, have no double bonds. Rather, they have just single bonds between the carbons. These are typically products like butter, which are solid at a room temperature. They are in general associated with a somewhat higher cardiovascular disease risk. Now finally, let's look at one more type, and these are really bad. When you go shopping in a grocery store and start reading the product labels, you will notice that the cheapest bakery products often have this thing called hydrogenated fats in them. What is that? The process of hydrogenation results in hydrogens in transconfiguration. Now, why is this bad? Well, in our bodies, these tend to form plaques, which build up as stuff within a blood vessel that result in the vessel becoming narrowed, and all sorts of further problems if the plaque breaks off and blocks a vessel. Not great. These are known to be associated with a higher blood pressure and heart attacks. So next time you go shopping, check if there are options other than hydrogenated products available for you. We find trans fats in many processed foods, including margarine, baked goods, and especially fried food. Okay, we are almost done with talking about fats, but two more things that I want to mention for you. Phospholipids are probably one of my favorite topics, and they will give us a nice segue to talk about cell membrane at the next chapter. But for now, what you need to know is that they have a head part, which is polar, and attract to water. Remember, this is where our friend glycerol is. They also have tail ends, which are nonpolar and avoid water at all costs. The final thing that I want to say about lipids is that, like I mentioned earlier on, we need some fats. What do we need those fats for, in addition to the fat-soluble vitamins? Well, for example, cholesterol is a precursor of steroids, which are important to us. When you will later in your studies talk about hormones, you will notice that it becomes obvious how hormones are needed for nearly everything. So let's finish here for now.